Like suppose if I start with the even signal or odd signal, I am giving some example to make you understand that how the signal can be the even signal or the odd signal. Suppose I have a continuous signal. I have a continuous signal. I don't know whether my signal is even signal or odd signal, but I have the continuous signal. So I can say that continuous signal x of t, if it is equal to x of minus t, if it is equal to x of minus t for all value of t. If this condition is satisfied, I can say that my signal is even signal. I will say that signal is even signal. So whenever you are going to determine whether a continuous signal or the discrete signal is the even signal or not, you have to look at this condition, whether it satisfies this condition, x of t is equal to x of minus t. This is the case for the continuous. If I have the discrete, I can determine whether the discrete signal is even or odd. So in that case, this will be x of n is equal to x of minus n. If this condition satisfied, then I can say the signal is even signal. I can say the signal is even signal, or I can say the signal is symmetric. I can say the signal is symmetric. But if you have x of t, or I can say that if you have if I have x of minus t, x of minus t is equal to minus x of t for all values of t, if it is x of minus t is equal to minus x of t, or x of minus n is equal to minus x of n in the case of discrete for all values of n, then I can say if this condition satisfies, then I can say that the signal is odd signal, or I can say this signal is antisymmetric signal. I can say the signal is antisymmetric. So these conditions you have to keep in your mind, that in order to determine whether a continuous signal or the discrete type signal, you can apply these conditions in order to determine whether the signal is odd signal or the even signal. So this is very important conditions that with the help of these things you can determine whether the signal is odd signal or the even signal.